Welcome to our second lecture on hyperbolic functions. In this lecture, we shall be treating inverse hyperbolic functions and hyperbolic equations. I am your lecturer, Professor E.O. Efanga. The inverse of Sinhx function. We define the inverse hyperbolic sign as follows. If y equal to Sinhx, then for any value of y, x is equal to arcsinhx y. We prove that arcsinhx y is equal to natural log of y plus square root of 1 plus y squared. Proof. Given Sinhx equal to y, then Coshx squared x is equal to 1 plus Sinhx squared x, and this is equal to 1 plus y squared. Taking square root of both sides, we have Coshx equal to the square root of 1 plus y squared. But Coshx plus Sinhx will give us y plus square root of 1 plus y squared. Also, Coshx plus Sinhx is equal to exponent x. Equating these two, we obtain exponent x is equal to y plus square root of 1 plus y squared. Now, taking natural log of both sides of this equation, we have x is equal to natural log of y plus square root of 1 plus y squared. So therefore, x, which is equal to arcsinhx y, is equal to natural log of y plus square root of 1 plus y squared. Example 1. Use formula to compute arcsinhx 3.4. Solution. We recall that arcsinhx y is equal to natural log of y plus square root of 1 plus y squared. Putting y equals to 3.4, we have arcsinhx 3.4 is equal to natural log of 3.4 plus square root of 1 plus 3.4 squared. And this is equal to natural log of 3.4 plus square root of 12.56, which is equal to natural log of 3.4 plus 3.544, and this is equal to natural log of 6.944. Either using a table or calculator, this will be 1.9379. The inverse of Coshx function. We define the inverse hyperbolic cosine as follows. If y equals to Coshx, then for y greater than or equal to 1, x is equal to arccosh y. We prove that arccosh y is equal to natural log of y plus square root of y squared minus 1. Proof. Given Coshx equals to y, then Sinhx squared x is equal to Coshx squared x minus 1. And this is equal to y squared minus 1. Taking square root of both sides, we have Sinhx equal to plus or minus square root of y squared minus 1. Now, Coshx plus Sinhx is equal to y plus or minus the square root of y squared minus 1. But Coshx plus Sinhx is equal to exponent x. Equating these two, we have exponent x is equal to y plus or minus square root of y squared minus 1. Taking natural log of both sides of this equation, we obtain x is equal to natural log of y plus or minus the square root of y squared minus 1. But natural log of y plus square root of y squared minus 1 can be shown to be equal to minus natural log of y minus square root of y squared minus 1. So therefore, we may write arc Coshx y as follows. Arc Coshx y equals to plus or minus natural log of y plus square root of y squared minus 1. And the principal value of this is arc Coshx y equals to natural log of y plus square root of y squared minus 1. Example 2. Use formula to compute arc Coshx 5. Solution. We recall that the principal value of arc Coshx y is equal to natural log of y plus square root of y squared minus 1. Putting y equals to 5, we have arc Coshx 5 is equal to natural log of 5 plus square root of 5 squared minus 1. And this is equal to natural log of 5 plus square root of 24. This is equal to natural log of 5 plus 4.899, which is equal to natural log of 9.899. Using either table or calculator, this will give us 2.2924. The inverse of tanhx function. We define the inverse hyperbolic tangent as follows. If y is equal to tanhx, then for y greater than or equals to minus 1, less than or equals to 1, x is equal to arc tan y. We prove that arc tan y is equal to half times natural log of 1 plus y all over 1 minus y. Proof. Given tanhx equals to y, then sec squared x is equal to 1 minus tan squared x, which is equal to 1 minus y squared. Cos squared x is equal to 1 all over 1 minus y squared, which implies that cos x, as taking square root of both sides, we have cos x equal to 1 all over square root of 1 minus y squared. Also, sin squared x is equal to cos squared x minus 1, which is equal to 1 all over 1 minus y squared minus 1. And this is equal to y squared all over 1 minus y squared. And taking square root, we have sinh x is equal to y all over the square root of 1 minus y squared. Then cos x plus sinh x. Cos x plus sinh x is equal to 1 all over square root of 1 minus y squared plus y all over square root of 1 minus y squared. Adding the two, we have 1 plus y all over the square root of 1 minus y squared. But cos x plus sinh x is equal to exponent x. So therefore, exponent x is equal to 1 plus y all over the square root of 1 minus y squared. Taking natural log of both sides of this equation, we obtain x is equal to natural log of 1 plus y all over the square root of 1 minus y squared. And this is equal to natural log of 1 plus y minus 1 over 2 times natural log of 1 minus y squared. This is equal to natural log of 1 plus y minus, note 1 minus y squared is difference of two squares and can be factored as 1 minus y times 1 plus y, and the natural log of the product is equal to the sum of the natural log. So this is equal to half natural log of 1 minus y plus half natural log of 1 plus y. When we open this bracket, this will give us half times natural log of 1 plus y. That's natural log of 1 plus y minus half natural log of 1 plus y will give us this. Then minus half natural log of 1 minus y. Half is common. When it is factored out, this will give us arctan y, which is equal to x, equal to half times natural log of 1 plus y all over 1 minus y. Example 3. Use formula to compute arctan minus 0.5. Solution. We recall that arctan y is equal to half times natural log of 1 plus y all over 1 minus y. Now putting y equals to minus 0.5, we have arctan minus 0.5 is equal to half times natural log of 1 minus 0.5 all over 1 plus 0.5. And this is equal to half times natural log of 0.333. Using table or calculator, we have half times that value is equal to minus 0.5498. Example 4. Solve the equation 8 Coshx plus 17 Sinhx equal to 20. Solution. Let us rewrite the equation as 8 Coshx equal to 20 minus 17 Sinhx. Now squaring both sides of this equation, we obtain 64 cos squared x equal to 400 minus 680 Sinhx plus 289 sin squared x. But cos squared x is equal to 1 plus sin squared x. Then this is equal to 400 minus 680 Sinhx plus 289 sin squared x. This will give us 64. When this bracket is open, we have 64 plus 64 sin squared x. When you cross everything to the right hand side, we will obtain 289 sin squared x minus 64 sin squared x, and that gives us 225 sin squared x. Then minus 680 sin x. Taking 64 to the right, we'll have 400 minus 64, and that will give us 336, then equal to 0. This is a quadratic equation in Sinhx, and we can solve this by factoring. The left hand side can be factored into 45 Sinhx minus 28 times 5 Sinhx minus 12, then equal to 0. This implies that either 45 Sinhx minus 28 is equal to 0 or 5 Sinhx minus 12 equal to 0. Therefore, Sinhx is equal to 28 over 45, which is approximately equal to 0.6, or Sinhx is equal to 12 over 5, which is equal to 2.4. Now, for Sinhx equal to 0.6, x is equal to arcsin 0.6, and this will give us 0.569. For Sinhx equals to 2.4, we have x equal to arcsin 2.4, and that will give us 1.609. We have come to the end of lecture 2. Thank you for watching, and keep on watching.